My name is Henrik Ingo, and today I want to show you something cool that we have added to the Otava incubating project over at Apache Software Foundation. But if you have no idea what the Otava project is or what is change point detection and why would you use it, then let me start by a short introduction. So Apache Otava is a project in the Apache incubator. This is change point detection for continuous benchmarking. So if you have something like a nightly build or maybe even for every commit you run some benchmarks, then you want to know where the regressions are in that history of results. And that's what Otava can find for you. When we deal with this kind of mathematical algorithm and change detection, what does it mean? What does it do? It can be hard to understand. Often it's better to visualize things if I want to see how the algorithm is going to perform on some specific data set. And now we have a demo app to do just that. So you can see what change point detection does. You can test different alternatives and you will see that actually Otava is typically always the best one. Ideally, your benchmark results should look like this. So every night you get the same result and it's completely clean and static curve, and then there is some change and it's of course easy to find and so on. But in practice your results are quite noisy, so it looks more like this. And actually let me add some noise just for extra fun. Click on analyze. So that's more like it. This is what we have to deal with. So where the noise and the change is basically same magnitude. So you can see that probably somewhere here something happened, but it's really difficult to say that is it here or here. Now Otava actually finds also like one extra change point just because it's goes so low there just before the change. So. But we can tune it with some parameters. So if we lower the p-value here, and this is p-value as is used in statistics. So anyway here it was able to find perfectly this one. So I'm gonna show you what happens. For example, often when you start doing continuous benchmarking, you think that okay, I'm going to do like threshold based alerts. So then like 5%, of course it's too optimistic when the noise level, we already know that it's like 20% or 20, but it turns out it's also 20%. So you might say that okay, but I'll set the threshold to 20%. So if a change is bigger than 20%, it finds it here. Here it's like going to 112. Previous point was 107. So no, 82 to 112. So clearly that's way above 20%. It's actually almost 30%. Right? So this would be pretty good. But the problem is that it's like very sensitive to finding the exact right percentage. And now if you had a change point that was smaller, like 20%, it would be missed. So this is very crude. Here we have 200 points, 37 are still flagged falsely just because of the noise, and there was one correctly found. So this means like a couple of, if this is nightly build, then this means actually like twice per week you will get a false alert just from this one time series. So it's kind of useless. I mean, how do you know out of 38 alerts that one was you should actually pay attention to? Completely useless. But there are of course other alternatives that are better. So the standard deviation one is if you've done like statistics 101 in college. This is like textbook stuff that many people think about, if they think about a little bit more. And but the surprising thing here is it actually finds 6 false positives, but it doesn't find the actual change point here. So and the 2 standard deviations is already quite low. I would like to use 3, so it would be more like 99%. But what if we use like 1.5 here? Still nothing. So now it's getting closer. So this one, we if you are kind of close enough, we give like a yellow marker. So this kind of counts as you know, not perfect, but well done. But here we have it's almost like 1 to 10, 1 to 8 is the ratio of correctly found change point and false positives. So this is still kind of annoying. It performs actually quite bad here. If you make it more sensitive, a smaller window, does it help? No, we just get more false positives. It doesn't get any better. So this was surprising to me when I started using this, because I expected actually more from this standard deviation one. So now you have 2 bad ideas: threshold-based alerts, completely useless; standard deviation, didn't actually find the change point, so not so good. The one that actually works relatively well is moving average. So now here we need to also lower the threshold a little bit so that it actually finds something. Oh, there already. So now it found a yellow one. Can we get it to? No. So this happens quite often, that many algorithms kind of can detect a change but cannot say exactly where it happened. And of course in this one it's kind of hard to, why is because the noise from here to here, this is like coming from random noise, but it's actually just as big as this one. So why is this one the change point and not this one? It's kind of arbitrary. So this is okay. But even then, Otava, in my experience, tends to actually find the right commit. And that's very useful, because this means we can, if you use Otava, you can just blindly send an email directly to commit author when you have tuned it well, so it works like this. So you don't need a human to check the output at all, because it can actually find exactly the right correct change point, not just alerting somewhere close. This is also useful because it alerts you to say that, hey, you know, you should look at this. I don't know where the regression is, but something is clearly wrong. So this is kind of nice as well. There are other modes. The next one is kind of like advanced. So here you can kind of build your own graph and so on in advanced way. Have fun. Alex already added, so you can actually, we have like a kind of demo data set that's from Tiger Beetle benchmarks in 2023 that we just use for testing and demos, and it's quite nice. But here you can also, you know, paste your own if you have the historical benchmark data. So now you don't need to install anything just take your data here, paste it in the box, and you can see how different versions of Otava will find change points in it.